This video will talk about the second left-hand rule. As we said on the first left-hand rule, what we were doing is that the thumb was telling us the direction of the charge because the charge was moving in a straight line, and the fingers were telling us the direction of the magnetic field strength. Now the charge is moving in coil. So it is, again, the second left-hand rule is telling us what is the relationship between the direction of the charge and the direction of the magnetic field. But the difference is that the charge is moving into a coil now. So if on the first left-hand rule, the thumb was telling us the direction of the charge and the fingers coiling the direction of the charge were telling us the direction of the magnetic field, now they will switch places. So now for the second left-hand rule, what we will have is fingers will tell us the direction of the negative charge. And if it is positive charge, then we just switch it. And the thumb will tell us the direction of magnetic field. So let's bring a picture here and then I will explain it to you. Let's suppose that we have the coil and then we are the electrons are flowing into it, or the current is flowing into it and the direction of it is given, and we are looking for the direction of the magnetic field. So where is north and where is south? Because if we know where north is, then we know where south is on the opposite side, or is it in the so that we can close the coil. So let's suppose that we have the direction of the electron flow. The direction of the electron flow is from A to B. So what you have to do is, with your fingers, you have to mimic the direction of the electron. So if that from moving from A to B, then when it is coming up here, then the electron will move this way, and then we'll go up here, and then so on and so forth. Okay, so now with your fingers, you mimic the direction of the electron, and then the thumb is going this way. So that means that this side of the solenoid, because this is a coil, the solenoid is north, and now we have to, based on the fact that the magnetic field lines are closed loops, then we have to close the loop. So we'll go around, and then this will be south, and we will continue within the page. So now if you place a compass somewhere in here, then the north of the compass will be this way. If you place the compass somewhere in here, the north of the compass will be this way. And if you place the compass here, the north will be this way. Keep in mind that the magnetic field lines are even on the bottom part of the solenoid. Okay, so it goes this one, and this one. So now if you place a compass here, then the north of the compass will be in this direction. Now if you have the direction of the intensity of the current, so let's suppose that we have a picture that is telling us that the intensity of the current, or the conventional current is on this direction, this is the same as saying that the positive charge is moving on this direction. So if the positive charge is moving on this direction from A to B, then the electrons will move on the opposite direction. So now your fingers, instead of going on the top part out of the page and on the bottom part into the page, now we will switch. So we will go on the top part into the page and the bottom part. So in top part here we'll go, because the electrons move. If the current goes from A to B, the electrons will go from B to A. So now the electrons will move on this one, this way, this way, okay, this way, and so on. So now the fingers will go on the top of this block here, will go into the page, and on the bottom of the block, of this block here, will go out of the page, telling us that the thumb is in the east direction. So this is telling us that in this direction we have north. And now since the magnetic field lines are closed loops, then south will be on the other hand, on the other side of the block, and we will continue with continuous lines here. So south will be here. So the same thing in here. Go from here and south here, here, and so if you place a compass at this position, then north of the compass will be this way, north of the compass up will be this way, north of the compass in this direction will be this way, and north of the compass will be this way. And now you saw it even on the first left-hand rule. If you know the direction of the charge, then you should know the direction of the magnetic field, or vice versa. If you know the direction of the magnetic field, then you should know the direction of the charge. So if I'm telling you that for the motion of the electron in this solenoid is producing a north on the left and the south on the right of the solenoid, in which direction is the electrons going? From A to B or from B to A at the electrons. So if we are talking now, then what we will do is we will define the thumb. But at first, thumb is, so this will be thumb. This will be the direction of the thumb, because the direction of the thumb is telling us the direction of the magnetic field. Now, the fingers will coil the block or the solenoid. And then what we see here is that the top part of the solenoid, the negative charge is going out of the page. So it is coming, negative charge is coming this way. It's coming this way. So it is going, electrons are going here, and then here, 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 and here. So the motion of the electrons are moving from A to B, while the intensity of the current is moving from B to A. So pay attention to what they are telling you, in which what they are looking for. Are they looking for the direction of the motion of the electron, or the direction of the intensity of the current, or the current, like the direction of the current. Okay, so let's bring some questions here that we are discussing of what is happening with the either magnetic field or first and second application of the left-hand rule, and then we'll stop this video here, and then we'll continue with the third left-hand. So what we are looking here is what is the direction of the compass. So in which direction the north of the compass is going when we have a bar magnet that has a north on this side and south on this side. Now, magnetic field lines are one continuous lines in the difference with electric and gravitational field, and they leave north and go to south. So they leave north and go to south. The direction is this one. Or they leave north and they go to south. Keep in mind, it doesn't matter what field lines you are drawing, gravitational, electric, or magnetic field, they never will cross out. Okay, they will never cross out. Okay, so now if you place the compass here, then magnetic north of the compass will be following the north or the direction of the field lines. And if you place a compass here, like somewhere in here, then it will be going like this. Okay, so and then if you place the compass here, then will be going east. If you place the compass here, then will going west, not east. And then if you place the compass here, will be going. And I said it that at this point is going up, but if it is very close, if it was here, then will be going like this. Okay, let's bring up another. So now we have two opposite poles, which we know that they will attract each other. But however, the magnetic field again will leave north and go to south. Okay, so magnetic field will leave north and go to south. Will be something like this. So now if you place a magnet here, then what the direction of the north will be, or the direction of the north of the compass will be this way. So now let's see those two individually, and then let's discuss what is the force between the two wires. So now we have two wires, and the electrons are moving, and the first one, in the first wire, they are moving out of the page. So the magnetic field that is created here will be concentric. So it will be something like this. B. Concentric circles that are, in this case, clockwise. And for the second one, when we have an electron that is moving into the page, then the fingers will tell us that the magnetic field created will be this one here. So now what do we see is that the magnetic field north is somewhere here, north is somewhere here, and then since they are like poles, what do? Do they attract, or do they repel? They will repel, okay? Okay. Let's bring another one similar to this. So now we have two wires. The direction of the electron is given. So on this case, they are both wires, wire 1 and wire 2 are both out of the page, the direction of the electron. So then the thumb will be out of the page and the fingers will show us the direction of the magnetic field. So for wire 1, what we have is a circle that B is this way. Okay. And for the second one, so again, B will be and so they are going in the opposite direction, which means that one is north and the other north is down and the other one is north is up. So that means that they will attract. They will attract each other. Okay, let's bring another question to discuss. So in this case, what we will see, or what is given, is a coil that we have direction of the intensity of the current given. The direction of the intensity of the current is the same as the direction of the positive charge. And if we are using the left-hand rule, then we will switch the direction. So in this case, the positive charge on the top part is going out of the page and then into the page. Okay, out of the page and into the page. So now, since it is positive and we are using left hand, we will switch it. So we'll go on the top part into the page and on the bottom out of the page. So this will be the electron. Okay, and here, the electron out of the page. Then the thumb will tell us that north is on this direction. And since the magnetic field lines are continuous lines, then south will be on the other one. And we'll have the same thing in here. Okay, so this will be the configuration of the field when we have a coil, but the direction of the intensity of the current is moving from A to B. Let's take a look at this other example. Now we have a coil that it is, if we are calling this A and this B, it is the intensity of the current is going from A to B, but the coil is on the top part is into the page and on the bottom part is out of the page. So if the intensity of the current is from A to B, then the direction of the electrons, so intensity of the current is from A to B. The direction of the electron is from B to A. So now we have from B to A, and this will be the north because the thumb is telling us that it is headed to west. Therefore, this will be the south, and we'll continue on. And the same thing on the bottom part. North, south. Okay, so the way that the coil is coiled, if that makes sense, and the direction of the electrons or the intensity of the current is telling us what is the direction of the magnetic field strength. I will finish here so that you can work on your own on the questions, and this is just in terms of the second rule for the left hand. The third part will be the third left hand rule.